Okay, I'm going to do another example problem. So I think I did this one in one of the periods, but I'll do number 5. This is again in the notes. So it says a toy car starts at y equals 3 meters. It accelerates for 2 seconds at negative 5 meters per second squared in the y direction and then suddenly stops. What is its displacement after 2 seconds? What is its final position? Okay, so I'll start with the picture. So instead of drawing a car, I'm going to draw a dot because it's easier to draw. You can do this on any problem you want. And then it says it accelerates for, it's starting at y equals 3, so I'll just make an axis that says y. I'll say this is y. We're going to say it's 3 meters. We're going to call this y. All right. It accelerates for 2 seconds at negative 5 meters per second squared, so I'll draw just that acceleration with the direction, so 5 meters per second squared. I'm drawing it that direction because it says negative 5 meters per second squared. So this is something we did a little bit with the walking activity and with the graphing displacements, but if we've got a negative direction on our speed or acceleration, that means it's pointing in the direction opposite the axis. So this would be the positive direction, that's the negative direction. Okay, and it's going to go for 2 seconds and then suddenly stops. What is its displacement after the 2 seconds? So it's going to start accelerating and it's going to stop after 2 seconds, so I'm looking for this position here. This is my initial position, so our symbol for initial position is x initial, final position is x final. Okay, so given that, now I'm going to write down what I need to find. It says what is its final position, what is its displacement after the 2 seconds, so those two things are delta x and x final. So I can find either one of those as my answer to this, and then I'm going to write down what I know already. So let me look through the problems, let me see what it gives me. So it accelerates for 2 seconds. So 2 seconds is a time. So I'm going to say time equals 2. For this column, I'm not going to put in any units. I'll do units at the end. But I think that makes it easier for plugging it in. All right, our initial position, x initial, I'm going to say that's 3. Our acceleration is negative 5. And what else does it give us? And then it says it starts at y equals 3 meters. It doesn't give an initial velocity, so we can just assume that it's starting from rest. So it's just starting at a standstill, and then it's going to start accelerating. So I can say that my initial velocity is 0, because it's not moving at the beginning. All right, so that's what I know. That's what I need to find. Here's my picture. My next step is looking at my equations, so I'm going to do that here. I'm looking for an equation that just involves things in this column. These are my options. I've got t, xi, a, vi. These last three all have vf in them. I don't have vf anywhere here, so I'm going to use the first one. Okay, so I'll write that down. So x final is equal to x initial plus, x initial plus vi times t plus 1/2 at squared. On the notes sheet, for some of you, it doesn't have the I here. This should say VIT. So if you have to make that correction, you can do that. But this is the right formula. Okay, then I'm just going to write down this formula again, replacing the letters with what they represent. So x final, we don't know, so we'll leave that as x final. X initial is 3. V initial is 0, so that's going to be 0 times t, which is 2. So 0 times 2 for that term, and then 1/2 at squared. So that would be 1/2 times negative 5 times 2 squared. That's a negative 5 right there. It's kind of hard to see. Okay. Next, I'll just simplify this. So x final is going to stay as it is, equals 3 plus 0 times 2 is just 0, so I'll leave that out. Or I guess I'll write it there. And then 2 squared is going to be 4, so I'll say that's the same as 1/2 times negative 5 times 4. I'll do another step of simplification, so just xf is equal to 3. I'll just get rid of this 0 here. And then 1/2 times negative 5 times 4. If I put that into a calculator, I'm going to get negative 10. So that would be 3 plus negative 10. So x final is going to equal negative 7. My units for position is meters. So my final answer would be x final equals negative 7. For delta x, we know that delta x is equal to x final minus x initial, which is equal to negative 7 meters minus 3 meters. So delta x is equal to negative 10 meters. All right. So that's how you do that problem.